In today's lesson, you're going to be learning all about vertex form. Okay, now we've talked about the parent function, right? This is the parent function for quadratics, meaning it's the simplest quadratic function. Okay, and I'm gonna write that parent function in vertex form. But then what we're gonna talk about is how vertex form can change a graph. Okay, so in vertex form, this parent function is 1, right? Okay, now you can see, right, that I've added a bunch of numbers, but I actually haven't changed anything, right? This is x minus 0, which is just x, and it's squared, right? Just like here, it's x squared. It's being multiplied by 1, which doesn't do anything. And then 0 is being added, which also doesn't do anything. So this is the same as y equals x squared, okay? But this is what's called vertex form. And you can see that in vertex form, there are 3 letters. We use 3 letters to represent these changes that can happen to the equation. The a, the h, and the k. So we're going to discuss each of those letters in turn and what changes they can create in the graph. And then you'll have a chance to practice that in a lot of different ways today. Okay, so let's start with the k, because the k is the simplest. Okay, this k, if it is a positive number, then the graph moves up that many units. Okay, so if it says plus 3 at the end, then the graph moves up 3, right? So this parent function is a parabola. It has a vertex at 0, 0. If it says x squared plus 3 instead, then it moves up 3 units. Now, if it's negative, it moves down that many units, right? So if this says minus 5, then it moves down 5 units. Okay, so that's k. Now, h moves the graph left and right. But what's a little tricky is, see how this says minus h, right? So this minus h means that if h is negative, that this will say x plus a number, right? Because it'll be x minus negative 5, or whatever it is, right? So if h is negative, the graph moves left. Okay, but remember that if h is negative, what it will look like is x plus a number, because that would be, right, if h is, let's say h is negative 3, that would say x minus negative 3, that would be x plus 3. Okay, now if h is positive, the graph moves right. Okay, but remember, that means that it's going to look like 8x minus a number. Okay, so another way of thinking about this, right, so this piece of information is here. Another way of thinking about this, though, is that if this is a positive, then the graph moves left, right? And if that sign is a negative, then the graph moves right. Okay, so it's a little tricky with the h, because in the formula it says minus h, right? So that sign gets a little tricky. Okay. Now the a has 2 functions. Okay, and the a is maybe like the trickiest one. So the first piece is, if a is positive, then the parabola looks like this. It's called upward facing. Okay, and if a is negative, it flips the parabola over, and that is called downward facing. Okay, now, the other piece about a is that if a is a whole number, right? Now, so now we're going to ignore the signs, right? So if a is 2 or negative 2, we've already talked about the difference between positive and negative. But so if a is greater than 1, okay, and that's either positive or negative, so this could be positive 2 or negative 2, then the graph gets narrower. Okay, and if a is less than 1, like it's a fraction or a decimal, then the graph gets wider. Okay, so that's what all these different pieces do. So what that means is that we can take a look at an equation like this one, and we can say, okay, how is that graph going to be different than the graph of y equals x squared? So I'm gonna do a couple as an example. so here, and we can just break it down piece by piece, right? And we can start wherever. We can start with the easiest, or we can start with the hardest, right? Doesn't matter. So let's just start, well, we'll go left to right here. So here, this 1/2, it's positive. So the graph won't flip, right? This will still be an upward facing parabola, just like y equals x squared, okay? Because the question I'm answering is, how will the graph of the given equation be different from the graph of y equals x squared? Okay, but this 1/2, right, if I multiply this by 1/2, it will be wider, right? This is 1/2 is less than 1, it's like a fraction or a decimal. So this graph will be wider than the graph of x squared. Okay, what else will happen to it? What does this mean? Okay, here, this is x minus h, so that means h is positive 5. Okay, so this will go to the right 5. Okay, and then this, k is negative here, right? If it's negative, it moves down. So this will go down 2. Okay, so for example, if this is y equals x squared, right, this graph will go right 5, down 2, and it'll be a little wider, right? So I didn't do a great job sketching that, but that would be basically the idea, right? It's a little bit wider. It went to the right 5 units, it went down 2 units. Okay. I'm going to do one more, and then what I would suggest you do after this one is pause it and try these two before I do it. Okay, now here, this one looks a little bit different. So what you can do is you can rewrite this. So here's the deal, right? What's missing here is this. So this is the same as, is this number next to the x. But you can see, right, what's happening here is that this number that's being subtracted from x is just 0. So if you need to rewrite it like this, that's totally fine, right? That way you can really identify that this is the a, this is the h, and this is the k. Okay. So what's different here? So this positive 2, this is positive, so it doesn't flip it. Okay, but it does make it, this is more than 1, it makes it narrower. Okay, let's see. It doesn't move left and right, right? This h is 0, so it's not going to move left and right. Okay, but it is going to go, this is a negative k, this is going to go down 1. Okay, so notice here is only 2 differences between the parent function and this graph. Here there was 3 differences. I'll tell you, here there's 4 differences. Okay, so what I would recommend doing right now is pausing it and trying these 2. Okay, and then seeing me do it. But I'm going to go ahead and do these 2 right now. Okay, so here I notice first off that the a is negative. So this graph is flipped upside down, right? It's going to look like this. It's going to be a downward facing parabola. This number is more than 1, right? So that's going to make the graph narrower. Now this is plus 1, right? Now remember, if that's a plus sign, this graph is going to move left, because what that means is that h is negative 1 here, right? This is x minus negative 1 right here. That's the same thing. So h is negative 1, so it's moving left 1. Okay, and then the k value here is 6, so it's going to go up 6. Okay, so that's all the differences between this graph and the parent function. Okay, here again, you notice this doesn't look quite like it's supposed to. You can feel free to write it, right? This is a negative 1 x plus 2 squared plus 0. Okay, so I notice this is negative, so it's going to flip. Okay, now this is a 1, so that doesn't change anything, right? If it's greater than 1, it becomes narrow. If it's less than 1, it becomes wider. But this one, it doesn't change anything. Okay, this plus 2, that moves it, right? Remember, again, this is the same as x minus negative 2, so that's left 2. And then this plus 0, of course, doesn't do anything. So for this one, it's just flipped and moved to the left 2.